Hello and welcome to Lyndall Brakes episode 1 of How It's Made. Today we're going to be talking about how we made the lightest, strongest monolithic race wheel for your Harley Davidson. Again, this is the lightest, strongest monolithic race wheel, and it's made specifically for your Harley. Bearing to bearing, hub face to hub face. This is designed, engineered, and manufactured specifically for high-performance Harleys and Harley Davidson racing. This wheel debuted and was actually manufactured for our King of the Baggers, Moto America. So today we're going to take an in-depth view of the materials and the methods of manufacturing a high-pressure forging. There are 3 ways you can manufacture an aluminum motorcycle wheel. There is a casting, there's a flow form, and finally there's a high pressure forging. This is the most expensive way you can manufacture a motorcycle wheel, or any other wheel for that matter. These are commonly used for military grade aircraft applications. These are commonly, in fact, this wheel is made of the same materials, made of the same manufacturing methods, and indeed the same facility that produces Ferrari's Formula One race wheels. So we're super proud to be able to bring this specific forging that allows us to make this most unique wheel in the world. Okay, so I'm going to get into some of the materials. This is a special blend from Duralcan of 6061, and it starts off as a billet. It's aged to the PT6 condition, and this billet is just that. It's a round bar stock of billet, and they'll saw cut it. They'll bring it to a temperature, and they'll place it into a tooling. Now this tooling is going to get smashed, so this material is going to get manipulated into the shape of the tooling. And when they manipulate it into the shape, it's done under like 80 to 100,000 pounds of pressure per square inch. So the rams that are involved in creating this pressure are like 12 foot in diameter, and there's basically 20 of them going around this platform. And then the tooling is in the middle, and these rams go like 50 feet into the earth and 50 feet above ground, and 2 hydraulic rams just smashing and pounding this material into this shape. And so during this process, what happens is the molecules start to take a granular structure, and indeed a very tight granular structure. And that's what allows us to make an aluminum wheel that's incredibly tough. And this granular structure is going in the load direction. And in the billet state, much like a casting or a flow form, the molecules aren't in any kind of arrangement. But during the heat and the frequency that's created under the super hydraulic load starts to align the molecules, and they get into this molecular grain structure, and that grain structure is going again in the direction of the load of the wheel. And then in this center portion, the granular structure is going from inside to outside. So this is, quite frankly, the toughest portion of the wheel, and it's the most load-bearing portion. This is where your bearings are going to go, and you're going to attach your attachments, whether it be a sprocket or a rotor. So this portion is going to stay super rigid. And then for the rim lip, to add additional strength, when you get this forging, it has the star pattern, but the forging doesn't have this rim lip in it as you see it. When you see this valley right here, the way the forging comes out, it's about this tall in this valley. So they'll take a mandrel and they'll cold roll this into this while they're turning it. I say cold roll, there is some temperature involved, but they're basically pushing a mandrel into this, and they're flow forming this. They're pushing and pulling this rim lip. So this is incredibly strong, way stronger than any other method of manufacturing, and way more expensive, I might add. So to get a high pressure forging, it costs a lot of money in tooling, and it costs a lot of money in the core manufacturing process. But having this super tight grain structure allows us to remove the most amount of material in our design, and that's how we can achieve the lightest and strongest wheel in the world with this high pressure forging. So we can cut our wall thicknesses down, and in this case to 135 thousandths wall thickness, which is very thin. And in the rim lip, we're at 80 thousandths wall thickness. So very thin, but exponentially stronger than a casting or a flow form because of the tight granular structure. So I'm going to put this back over here. Now we've talked about our materials, and not only do we have our materials, but we have our material certs, our certificates of inspection for those materials, and then we have our certificate of compliance for this forging. So when they manufacture this forging, they'll actually make 3 pre-trial run forgings, and they'll cut those in half, and they'll measure the granular structure, they'll measure the density, they'll measure the hardness to inspect for the heat treat. Then you'll get a certificate of compliance once this forging and this specific batch has met the engineering requirements of this forging. So we have, this is fully pedigreed. Again, we have all of our material certs, every inspection document, and this is thoroughly vetted for the process of making actually an aircraft wheel, but we decided to make a motorcycle wheel out of it. So now we've talked about high pressure forging, and I'm going to start with the cheapest way to make a wheel with the least amount of cost and least amount of structural integrity. We all know that the factory Harley Davidson wheels are cast. And so here's a factory Harley cast wheel. This dude weighs about 17 pounds in contrast to our 8-pound wheel, much heavier and not nearly as strong as our wheel. So in a casting, they'll take a molten 6061 and they'll pour it into a mold. That's what would be called a gravity fed casting. So they let gravity feed the mold, and then they'll pop this out and machine it to its final. But it'll have most of its dimensional design characteristics integral to it in the cast process. Another way to cast a wheel is called a pressurized casting, and it's the same as a gravity-fed casting, only it's under positive pressure. Again, no granular structure involved in it. It's just a cheap way to make a shape where you have the least amount of cost in it, but the sacrifice is you have the least amount of structural integrity. So next I'm going to move to a flow form wheel. Like typically all the modular wheels that are on the market, these are flow form. They call them rotary forged, but that's a fancy label for a flow form. In a flow form, it starts off much like a casting. The base part is cast, and then what they'll do is they'll heat that casting and they'll draw out the rim lip and this shape. So it gives you a little bit of a grain structure, not a very tight grain structure, but you will start to get a little bit of granular structure in the flow forming of this. So it is stronger. It's quite a bit stronger than a cast wheel, but not nearly as strong as a high pressure forged wheel. So, but it's a good, sort of happy medium between the cheapest and the most expensive wheel. Good happy medium right here. And another advantage of having a flow form is you get a nice smooth surface to work with because it's drawn out. So again, you have the cheapest way with the least amount of structural integrity right here in the factory cast wheel, a little bit of upgrade in the flow form, and then finally you move to the high pressure forging. The one thing they all have in common is they're all 6061 aluminum. This is a specific blend. It has a much higher elongation factor, which means that it will bend rather than break. And that is because of the tight granular structure and some of the material properties. This is a specific blend specifically for military grade aircraft wheels. So now we've covered the processes of manufacturing, the materials of manufacturing these wheels, and what it is to have a high pressure forging. But back to the weight, the advantage that this wheel has over its counterparts. When you can remove this amount of material and keep a greater amount of structural integrity, you have many improvements in chassis dynamics. So this wheel, because it's so light, when you hit irregularities in the road, your chassis absorbs them way better. It's not feeding this big, heavy 17-pound wheel into your suspension and your chassis. So this wheel will soak up irregularities, and because of the lightweight, it will simply spin up so much faster. Most of the weight in this wheel is in the center portion in the hub area, and the rim lip has the least amount of weight in it. So if you've ever seen a figure skater when they're spinning around and they have their arms out here and they're going slow and then they pull their arms in and they start to spin super fast, that's because they've reduced all of this extra inertia out here. And they've brought all of that into the core. And so this wheel will spin up super fast, and it'll also decelerate really fast because of the same reason. It's light. So this will absolutely change the way your bike handles, the way it absorbs irregularities in the road, the way it accelerates and decelerates. Not only is it a beautiful piece, but it's probably, outside of a performance engine, the biggest upgrade you could do to your performance and handling. So if you guys have stuck with us this far in the video, we are mightily impressed. Please put your comments in the comment section. We're going to be doing a specific episode regarding those, and so we're looking for those comments. If you have them, please chime in, and we'd like to thank you for joining us, and we'll see you on the next episode. Thanks.